Good afternoon, everyone. This is Mr. Fitri again, coming to you from our virtual classroom. We're going to continue Unit 1, which is Introducing the Earth, with our lesson focused on Earth's interior. All right, let's get started here. Again, we have two objectives. Number one, how do geologists learn about Earth's interior? And the second one is, what are the features of Earth's crust, mantle, and core? Both of these will focus on Earth's geosphere. If you recall from last class, the geosphere is Earth's land, or the land of the Earth, I should say. Okay? So we're going to focus on that today. Per usual, we have several vocabulary words. Okay? First one is geology, the science of the earth. Okay. Again, that's geology. Next one is a geologist. Okay? This is a person who is an expert or a student of geology. So they want to understand and learn about how the earth works. All right, so the science of the earth. Next we have pressure, a force pressing on an area. Next one, molten, okay? Liquefied by heat. Okay? So what we'll see here later on is that if rock or metal becomes hot enough, it will actually turn into a liquid. Okay? Yes, rock and metal, if hot enough, will become liquefied, will become a liquid. Next one, solid. Okay, this is firm and stable, not liquid. Okay? So if you look to these pictures I've included in the slide, okay, the left picture is liquid, okay, liquid water. The picture on the right of Squidward is actually of a solid, okay? Water, all right, frozen becomes a solid, becomes ice, okay? Sorry about that bing there. Last one, okay, is interior. This means inside, okay? So we're not just talking about the interior of the earth. This could be a vocabulary word for anything, okay? The interior of your home, the interior of the school, the interior of the refrigerator. I don't know, whatever you want to use it for, okay? Whatever's inside. Okay, good. Again, like I said last time, if you don't understand one of these words, I would suggest translating it, okay? Either on Google Translate or pull out a dictionary, okay? So let's get into our first objective. How do geologists learn about Earth's interior, okay? How do geologists, remember the experts of the science of the Earth, learn about what is going on inside of the Earth? First of all, we should know that geologists can't look into the center of the Earth. Okay? The Earth is massive. It's very, very big. And we can't just look into it. All right? So they study the center of the Earth two ways, through rock samples and seismic waves. Okay? The pictures you see here are geologists doing core samples. Okay, the left picture is a core sample of the Earth. Okay, they dig a a hole, essentially like a tube. They pull out what they find. And you can see different layers, okay? Maybe some rock layers, maybe some muddy dirt layers, perhaps some clay. So you get to see what type of rocks, what type of minerals, what type of dirt, what type of elements are in the earth at that location, okay? So the first of these two is rock samples, okay? So like I just showed you in that picture there, in the last slide, was that geologists will drill holes and bring up rock. Okay, so they'll drill holes to figure out what kind of rock is below that portion of the earth. Okay. It should be noted that also when volcanoes erupt, like you see on the right there, they bring up rock from deep inside of the earth, okay? So they might actually bring up more rock than the scientists can drill a hole for. So both of these techniques of looking at rock samples help us understand what the earth is made up of. And I want to note that rock samples vary depending on where you are. Okay, the rocks below our feet in Bangkok will be different than the rocks below Chiang Mai, or the rocks in Beijing, China, or Tokyo, Japan, or New York City, United States. Okay, so they differ, and that's important to note. The second technique of understanding the earth is through seismic waves. Seismic waves are the vibrations, okay, the movements produced by an earthquake. Okay? And geologists study how these waves travel through the earth. On the left, the little GIF you see moving around the picture. Okay? These are the three types of waves that are emitted during an earthquake, okay, that are released. And each wave moves at a different speed and does different things to the rocks below our feet. Okay? And this allows geologists, it gives geologists clues about the structure of the planet. Okay? Now, we will be looking at each of these a little bit more closely when we look at earthquakes later on in the term, okay? But just know that this is one way geologists study the center of the earth, okay? So, again, our objective review here. How do geologists learn about Earth's interior? Well, 1, rock samples, all right? If you look to the right, I include this little GIF of Minecraft, okay? Because it actually gives us a good idea of how geologists study the earth, okay? For anyone that plays Minecraft, when you dig around, you don't always find the same thing, right? You might find iron ore at one place, coal at another, maybe diamonds close to lava, okay? So Minecraft is very similar to the Earth, okay? Different rocks, different minerals, different things will be found in different areas. And the other one is seismic waves. That's the left picture there, movement of the Earth, okay? Again, seismic waves are the vibrations released by earthquakes, okay? Cool. Now, objective number 2. What are the features of Earth's crust, mantle, and core? Okay. So, to begin here, we need to understand that Earth's geosphere is made up of 3 main layers, okay? Crust, mantle, and core, okay? For anybody that's seen the movie Shrek, okay, which is the little gif there of the donkey and ogre, okay? Shrek is telling the donkey there, no, onions have layers. It's just like the earth. The earth has layers, and each are a little different than the other, okay? Now, what about these layers? Well, the layers vary, okay, they differ in size, composition, temperature, and pressure. Okay? Now we'll look at the first two, size and composition of each layer. But what we need to know about temperature and pressure is that as you go deeper in the earth, okay, the more you go towards the center of the earth, the greater the pressure and the higher the temperature, okay? Until you get to the core, like you see in this picture here, that is very, very, very hot, okay? So hot that it has melted rock and metal and made them liquid, okay? Molten. Again, going back to our vocabulary words. Good. Now let's look at these layers. First is the crust. We nickname this the skin of the earth. Why? Well, because it's the outside layer, right? When you look at your friends, you don't see their bones or muscles or stomach or heart. You see their skin, right? Same thing with the crust of the earth. Okay, this is what we see. Now, the crust includes both the dry land, right, where we live, and also the ocean floor. Okay? Now, this is the thinnest layer of the earth, okay, on average between 5 and 100 kilometers thick. Okay? Now, I include a little piece of, or a gif of pizza, because pizza, okay, has that little strip of bread around the edge, right? You get your round piece pizza. On the outside, there's that bread. Well, we call that the crust. So try to think of the Earth's crust as being like the pizza crust, okay? The outside edge of it. Now, the crust varies, okay? Oceanic crust, okay, the crust under the ocean is made up of basalt. Okay, that's a type of rock. And we'll look at these a little later when we talk about rocks and minerals. Not only how it's made, but also why the oceanic crust is made up of basalt. Okay? Continental crust is made up of granite, right? Another type of rock. And as you can see from the picture, oceanic crust tends to be thinner and continental crust tends to be thicker. Okay? The next layer, as we go deeper in the earth, is the mantle. This is the middle layer of the earth. It is made up of rock that is very hot but solid. Okay? It's nearly 3,000 kilometers thick. It has a lot more magnesium and iron, right? Two elements. Has a lot more than the crust. And we also divide the mantle into 3 layers. Okay? The lithosphere, asthenosphere, and mesosphere. Okay? Again, like our atmosphere, don't worry about memorizing those different layers. Just know that yes, there are different layers within the mantle. Okay? And once we get to the very center of the earth, okay, we come to the core. Okay? Again, this is the center of the earth. It's made up of the metals iron and nickel. Okay, again, 2 metals, also 2 elements. Now this has a radius, okay, of around 3,480 kilometers. Okay, so mantle and core, very thick parts of the Earth. And the core consists of two parts. The outer core, the outside core, is a layer of molten metal. Okay? Metal so hot that it is a liquid. The inner core, on the other hand, is a dense ball of solid metal. Okay? It's cooled enough that it has become hard once again. Okay? Again, just to emphasize, molten, liquefied by heat. Okay? So hot, it has become a liquid. So, our objective review here. What are the main features of Earth's crust, mantle, and core? Well, again, the crust, these are the things I want you to remember. Crust, 5 to 100 kilometers thick. It is solid rock, and we call it the skin of the Earth because it's the outside layer of the Earth. Below that is the mantle, 3,000 kilometers thick, made up of magnesium and iron. It is hot, but it is solid, okay? And the core, this is the center of the Earth, okay? It's made up of metals, okay? And has two different parts. The outer core, okay, which is molten metal, okay, liquefied metal, and the solid metal center, okay, the inner core, okay? And again, both of these are made up primarily of iron and nickel. All right, so that concludes lesson number 2 here. Again, if you're curious or don't understand any of the vocabulary or topics, definitely go back, try to translate it, maybe that will help you, but also feel free to ask any questions you may have. All right, thanks so much, and we will see you in the next class.